So now we're going to talk about types of muscle contraction. So we've got a couple of objectives for this one. So we're going to differentiate between tension and contraction. So tension is just how much overlap is there between actin and myosin. Okay, and so this has everything to do with the number of cross bridges, right? More cross bridges, more force. Okay, or more tension. And then we've got contraction, and this is just how we generate that tension. But it's important to know that contraction doesn't mean there's actually shortening of the muscle. It just means that there's tension in the muscle. Okay, and so just think about now, is there any, as you're sitting there, do you have any muscle contraction going on? Skeletal muscle contraction? And the answer is yes. Okay, and the reason you know that, like I said a couple videos ago, you're not floppy on the floor. So there's got to be some sort of contraction and tension, otherwise you just be a blob. Okay, and so even though you might not be doing anything and you're not moving, there is muscle contraction. All right, now we talked about motor units, and the way the motor units work is it's is through the all or none principle. When it comes to neurophysiology, either you have an action potential or you don't. Muscle physiology is very similar, okay? So if you have an action potential in a motor unit and that stimulates a muscle fiber, activates a muscle fiber, causes an action potential in a muscle fiber, that motor unit or the muscle fibers in that motor unit are going to contract, and they're going to contract maximally, okay? Now, this is important. So they contract maximally. They don't do just half their effort. All right, and so the way we generate different amounts of force in a muscle is, well, it's dependent on how many motor units are we actually recruiting. So when it comes to a muscle twitch or kind of that contraction, there are three parts to it. So we've got the latent period, the contraction period, and the relaxation period. Now notice this happens relatively quickly. We're talking 100 milliseconds, which is about 1/10 of a second, okay? So let's talk about each of these. Well, the latent period is how long it takes the action potential to travel down into the sarcolemma, okay? So just because you have a stimulus, it still takes time for that action potential to travel. Then you've got the contraction period. This is where calcium and troponin get together, moving tropomyosin out of the way. You get cross bridges, so actin and myosin are bound together or connected. And ultimately, if it's happening, muscle contraction begins to occur. And then the final period is this relaxation period. Okay, so tension goes away. We do this by pumping calcium out of the sarcoplasmic reticulum, or pumping it out of the sarcoplasm into the sarcoplasmic reticulum. Okay, so let's just say here's our cell, okay, and here is the sarcoplasm. We got a lot of calcium in here, and you'll always have more calcium inside than outside, okay. I'm trying to show that this is bigger than this, didn't do a good job. Okay, and then here's a pump, and it goes against the gradient. So this is our calcium ATP pump. Oh, that's just hideous looking. I really need to get a stylus or something that I can write on. Okay, so that's the calcium ATP pump. And so we're constantly pumping calcium back into the sarcoplasm. All right, and so then I want to show you how tension can be affected by how often a muscle is stimulated. Okay, and so if you notice, this is just a muscle fiber, and it's showing what happens if we stimulate it frequently. Okay, notice that the tension increases every time. All right, there is this relaxation period, but if we generate an action potential before it's all the way relaxed, we generate more tension and more tension and more tension. Okay, if we ever get to where we're generating max force or maximum tension, it's because we've got complete and sustained stimulus, and that's tetanus. Okay, so we've got a couple of different terms for this. So we've got TREP, which is just this step-like increase. So as we stimulate the muscle frequently, we're going to generate more tension. This is showing that TREP right here. Okay, so right here, this is TREP. Tetanus is where you have the constant contraction because there's no relaxation phase, like you're constantly stimulating the muscle. And then we've got summation, and so that's all that's happening there is that we're adding the force of successive stimuli, basically. All right, and so we're seeing this here. So we've got a little bit, and a little bit more, a little bit more, a little bit more. So we're summing those forces together. Now, remember I said earlier that a muscle has many motor units, but we don't necessarily activate all those motor units at once. Okay, we actually activate them in a specific order that we'll talk about on the next and final slide. But I want to show you something here. So each of these motor units will have a different stimulus that's needed to cause them to reach threshold. Okay, and so we've got this line here, and whatever the number is, that's the minimum threshold needed to activate any of the motor units. So in this case, it's 3, right? That's our threshold. All right, and then there's a stimulus up here where once we hit that stimulus, we've activated all motor units, okay? And so that's 7. All right, so if we're below 3, notice that we don't activate any motor units. There's no tension or contraction that's occurring. But then as the stimulus gets bigger, so we're just going to say it's a size 3, well, we activated 2 motor units. And then we go up to 4, we activate those same 2 motor units and then a couple more. We go up to 5, a little bit more, 6, a little bit more. And if we stimulate or have that threshold or that stimulus at 7, that's where we, in this case, activate all of the motor units. And so it doesn't matter if I have a stimulus of 8, 9, or 10. Once I've activated everything, I've activated everything. And as a result, if you notice, we reach maximal contraction once we hit, in this case, a stimulus of 7, because 7 will activate all motor units, and once they're all activated, you can't activate any more. All right, and so the way we recruit motor units is in order of their size. We go from smallest to largest. Okay, and remember we do this we're able to do this because they have different thresholds at which they're activated. The small motor fibers, muscle fibers, have a low or a more negative threshold, whereas the big ones have a less negative threshold. Okay, so the purpose of this is so we're efficient. We don't need to use our big fibers immediately. Okay, we have this buildup. All right, there's a couple of ways that you could look at this, the benefit of this. 1, it's efficient, right? 2 is there's a lot of things that we do where we don't need a lot of force. I like to cook, I like to bake. I'm not as good of a baker as my wife. But the other day I made a flourless chocolate cake and it was delightful. And one of the things that goes into a flourless chocolate cake is a lot of eggs. And so you have to break eggs, right? So just imagine if you were generating maximum force just trying to pick up an egg, let alone break an egg. Okay? If you're using maximum force to pick up an egg, you're going to smash the egg and you're going to have it all over everywhere. That's not great. Okay? And so we don't do that. We start with our small motor units and then we build up if we need to. And if we've got generate too much force, your brain thinks, oh, I'm going to need X amount of force and you don't need that much. It also can turn that down, right? We've all experienced those times where you thought you're going to pick up something really heavy. And as you do that, you like almost throw whatever it is you're picking up through the ceiling, okay? Because you've recruited too many motor units. And then there's also those times where you think something's going to be really light and it turns out to be really heavy and you start to move and you're generating lots of force and you're moving quickly and you throw your back out because you're trying to move quickly but you're not generating enough force to move whatever it is you're trying to move. And so we're going to end there with muscle contraction.